Hello, hello. So in this video, we're still recapping the algebraic fraction stuff from first year. And if we take a look at the question here, it says, show that 3x minus 4 is a factor of this cubic. So to show that something is a factor, we're going to have to use a factor theorem. So we need to figure out what the solution would be from this, and we plug it into our expression. And then afterwards it asks us to fully factorize the expression, which at that point would be quite easy because they've already given us a factor. So this is actually maybe a bit easier than some of the videos we've already done because we're not having to figure out the factor ourselves, we're being given it. So to prove it, we've got to first of all think, if 3x minus 4 is a factor, then what would the solution be? And that would be 4 over 3. So what we need to do is plug 4 over 3 into this and see if it gives us 0. Yeah. So we could express it like this if we wanted to. And we'd have 6 times 4/3 cubed minus 5 times 4/3 squared minus 7 times 4/3 plus 4. We have to put all that into the calculus in one go. And that does indeed equal 0. So we know that this is a factor. Yeah, that's it. That was meant to be a tick. So we've proved that there is a factor. Next up, we need to fully factorize it. So we're going to have to divide this cubic by this factor using the remainder theorem. So we've already got, well, I've written out the expression here, and we're going to divide this by 3x minus 4. So like always with these things, first thing to do is divide the 6x cubed by the 3x, which would give us 2x squared. So I pop the 2x squared here. I always pop it here because it's above this x squared, but some people put it over here. To be honest, it doesn't really matter. Then we can multiply this 2x squared by each of these. So that would give us 6x cubed minus 8x squared. And then we're going to do these two terms, take away these two terms. So negative 5x squared, take away negative 8x squared, the same thing as adding. That will give us positive 3x squared. And then I'm going to pull down this next term. Then whole thing repeats. So I now divide the 3x squared by 3x, which just gives me x. And then multiply that x by each of these. So we get 3x squared minus 4x. Then again I subtract. So these cancel out. Minus 7 though, take away minus 4 is like adding. So now I get minus 3x. Pull down the positive 4. Repeat same thing. So minus 3x divided by 3x is minus 1. Minus 1 times these two things is minus 3x, add 4. And because these are the same, when I subtract them, it's just going to give me 0. And that's it. That's what we were expecting. So we already proved at the beginning that 3x minus 4 was a factor. So we kind of knew that we should end up with 0. And if you do this but you don't get 0, it's fine. It just means you have to redo this because you probably made a little mistake somewhere. And to be fair, these are really easy to make mistakes, and I quite often get my minuses or pluses mixed around or something. It's quite easy to make little mistakes, so I wouldn't worry. But basically what that tells us, importantly, is that we can express our cubic as 3x minus 4 times this, because this here is the other factor. The 2x squared plus x minus 1. Yeah. So what we've done here is we've taken this purple thing and divided it by this, and that gave us this expression here with nothing left over. So the very, very last thing we need to do to fully factorize it all is just factorize this quadratic part that isn't fully factorized yet. So because I've got to make 2x squared, I'm going to write out 2x in one bracket and x in the other one. Then I'm going to come up with two numbers that multiply to make minus 1, but will add when you take this 2 into account to make positive 1. So that's just going to be minus 1 here and plus 1 here. And that's it. That's fully factorized. So that is that question entirely done. So I hope that all made sense. If you have any questions, let us know down in the FAQ. But otherwise, have watched the other videos and certainly make sure you have a go at the MCQs at the very end of the topic. And I'll see you next time. Thanks.